Hello, class. This is Mr. Hart. And in this podcast, we want to start the unit on magnetism. Okay? And so, this is also a fun unit like electricity because everyone has played with a magnet before. You probably were awed when you first saw the first magnet that would hold to the fridge. And when you're a little kid, you probably played with them like crazy because they thought they were so cool, right? And so, in this unit, we want to be able to describe how magnetism works and, of course, be able to calculate things like magnetic force and stuff like that. Okay? But, like always, before we get into it, let's think about what in the world is magnetism. Okay? You've played with it before. You've seen North and South Pole magnets, horseshoe magnets, bar magnets, okay? Those cool, like, cylinder-looking ones that can roll down the fridge and stuff, okay? Everyone's seen a magnet before, but what is magnetism itself? What causes it? Okay, and it's going to be created from electrons. Okay, it's going to be dealing with this, subatomic world that we keep talking about. Okay, and so magnetism is an attraction or repulsion between objects because of motion of electric charge. Okay, and so we'll talk about this more when we get into electromagnetism. But magnetism is a separate effect that comes because electric charge is moving, okay? And so inside bar magnets, inside permanent magnets, inside any type of magnetic field, there's some type of electron that's moving. It's not the electric force itself, okay? It's kind of separate from the electric force, but it's caused by electron motion, okay? It's kind of a separate phenomenon that occurs because of electron motion, okay? And so when that motion occurs, we can get a magnetic force that is caused between two magnetic objects, and you can get a magnetic field that kind of describes how that magnetic force is being propagated from an object. Okay, so very similar to what we described in electricity, right? So you have this phenomenon of magnetism. It causes magnetic forces, and we can visualize it in terms of magnetic fields. So you'll see very similar drawings to those we saw in electricity. Okay, but let's just start with the fundamentals, okay, things you understood when you were a little kid, right? So every magnet, instead of being positive and negative, we describe it as north and south, okay? So that kind of comes from the idea that the Earth had a north and south pole, and the first magnets were used for compasses, and so there was a north side of the magnet and a south side of the magnet, okay? So instead of being positive and minus, we have north and south, and just like with electrons, like poles repel and opposite poles attract. So if you put a south and a south together, they'll push away from each other. Okay, if you put a south and a north together, they'll come together. So this is very similar to what we saw with electricity, right? Like charges repel and opposite charges attract. With magnets, like poles repel and opposite poles attract. Okay, same thing. Okay, a cool thing that comes from this, though, that you won't see with charges is because these are usually objects themselves, like bar magnets, right? You can actually get this phenomenon occurring, okay? You can't isolate magnetic poles, okay? And because of that, if you break a magnet, each piece will have a north and south pole. So this is kind of a cool thing with magnets, if you think about it, okay? Because it's caused by this electron motion, this motion always causes a north and south pole, okay? And you can think of it inside of the magnet, you can think of it like this. Okay, you can describe it as like little arrows almost pointing towards the north side. Okay, so inside that whole bar magnet, there's this magnetic field, you could say, pointing towards the north side of the magnet. So if you split that magnet in half and you cut it in half, well, this side of the magnet still has arrows pointing this direction. So even though you cut that magnet in half, well, guess what? There's still a north side and a south side. And this one still has a north side and a south side. And if you do that again, you still get the same thing occurring. And you can split that up a million times, okay? And even if you get down to, like very small microscopic pieces of magnets, guess what? They still have north and south poles, okay? You can't isolate them because the electron motion always causes a north and south side. So you can break it up, split it up, cut it at weird angles, any of those things, you still get a north and south side, okay, to the magnet. So now that we have the fundamentals, let's talk about the different types of magnets. So because you've probably noticed not everything's magnetic all the time. Okay, you have those permanent bar magnets, but sometimes metal behaves magnetically. Sometimes, you have those fridge magnets, and they'll stick to the fridge, but nothing else, right? There's a lot of different types of magnets. So let's go through the different types that you'll see. Okay, so there's 4 common types of magnets. There's permanent magnets, paramagnets, ferromagnets, and electromagnets. Okay, and so permanent magnets are what you would expect, those things that permanently maintain those magnetic properties. Bar magnets, horseshoe magnets. Okay, those are permanent magnets that are always magnetic. Okay, they always have their magnetic properties. They always have a north and south side. So paramagnetic materials are things that are magnetic, but only if they're in a magnetic field or near something that has a magnetic field. Okay, so think about like those fridge magnets that you get with like the newspapers sometimes that are ads for certain companies. If you've ever taken one of those, they're pretty flimsy, right? And if you try and have them stick to anything else like a bar magnet, they usually don't work very well. Okay, they're not a magnet themselves. They're not a permanent magnet. They're only paramagnetic, meaning if you stick it near something that is magnetic, then it will become magnetic itself, but otherwise it doesn't behave like a magnet. Okay, and so that's a paramagnetic material. And then a ferromagnetic material is a material that retains its magnetic properties after it's been placed in that magnetic field. We'll take a look at this in a second. And then the last one is electromagnet, okay? And that's a material that becomes magnetic when electricity flows through it. And those are really cool. And we have a whole unit based on those, okay, with electromagnetism. Okay? Let's just go through these each quickly, okay? So the first one is permanent magnets, okay? And there's all sorts of types like we talked about. These are called neodymium, I believe, permanent magnets. And they're very strong, right? They always have those magnetic properties because the electrons have been basically lined up in such a way that they always have those fields that they make, okay? And so bar magnets, these magnets, okay, they always have those magnetic properties to them, okay? And then paramagnets, again, are like fridge magnets, okay? They only stick if they're near something that is magnetic, okay, or can become magnetic. So the reason that a paramagnetic material works is because of looking at the field lines, okay? So if you think about a permanent magnet, okay, I kind of showed that if you draw the north and south side, we can think of the magnetic field as having arrows pointing up towards the north side, right? Okay, and it's always that way. It always has that magnetic property, okay? In comparison to paramagnetic, if we draw it, okay, normally the object just has its magnetic lines or magnetic fields just kind of pointing in all sorts of directions. There's not any rhyme or reason to it, or, it's not going to have any magnetic properties. But once it gets near something, these lines are going to kind of align with the magnet itself. So if you put it near something, those properties change, the field inside the material changes, and now they are pointing towards the north side and the south side, and it becomes magnetic in nature. Okay, so fridge magnets, a lot of metals are this way. Okay, those are paramagnetic material. Okay, or sometimes called paramagnets. Okay, and then ferromagnets, okay, are like iron and other metals. Okay, so same thing, right? Usually, if you just have the object, they don't have any rhyme or reason to the lines, but when you put them in a field, okay, then those lines line up, okay, they become north and south poles, right, and it becomes magnetic, okay. But the cool thing about ferromagnets are that as soon as they get away from the magnetic field, they still retain those properties, okay, for a while, okay, sometimes forever, depending on the substance, but they'll maintain those magnetic properties for a time. It will take a while for the fields to get out of line again, and so they'll stay magnetic for a long time, okay. So iron's a very common one. Okay, if you put iron near a magnetic field like an iron nail, and then you stick it near another magnetic material, even though it wasn't magnetic, it will stay magnetic for a short time. Okay, so like you can put iron in a magnetic field, and then you can take the iron nail and pick up paper clips and things like that. So it's kind of cool. Okay. All right, and then the last one is electromagnets. And so if you put electricity through a wire, for example, and you wrap it around in a coil, then you can use the nail inside of it to pick up things, right? So the wire that has electricity flowing through it can make a magnet, okay? And like I said, we have a whole unit dedicated to this, so we won't go too much into how that works right now. But basically, if you flow electricity through it, it becomes magnetic. So the really cool thing about this, though, is that you can turn that magnetic field on and off, right? If you let electricity flow, then it's a magnet. If you turn electricity off, then it's not a magnet, right? So this is really useful. A very common example I like to think of is think about those like gates at Disneyland or another theme park, right? Where for safety, they have to make sure the gate's closed, but at the same time, they still have to let people through when the ride's over, right? So what they do is they put a magnetic electromagnet on the edge of the gate, and then when the ride's going, there's electricity going through the magnet, so the gate won't open, right? So they'll put electricity through that magnet, the gate shuts, you can't open it because there's a magnetic field holding it closed, and then as soon as the ride's over, the electricity stops flowing, the gate can open freely, guests can go through, and stuff like that. So really cool invention. It's revolutionized the world in a lot of ways, but we won't see all the ways until, again, that next unit on electromagnetism. Okay? But anyways, so those are the different types of magnets. Okay, permanent magnets, paramagnetics, ferromagnetics, and electromagnets. Okay, and so just kind of a basis of magnetism. For the assignment for today, it's a lab just to kind of see how magnetic fields work. Okay, so you'll be doing a lab on the direction of the magnetic fields and the strength of magnetic fields. You're going to be using the Vernier software and equipment, so you'll need to do this one in class. Okay, so that will kind of give us more foundation for the next lesson when we try and describe and draw magnetic fields. Okay, but that's all we're doing for today. Let me know if you have any questions, and thank you for watching.